Hey Algebra 2, we are getting ready for Unit 6, our test coming up next Wednesday, and we're going to go through Unit 6 review on rational functions. So what I would recommend you do is have your notes along to accompany you as we go through this, because that will be very helpful in figuring out what you need to do. All right, so let's get started. So on this first one, let's make sure I got the right color here. Start with red. We are looking at this graph, and the instructions say we need to find the points of discontinuity, vertical asymptotes, horizontal asymptote, domain, and range. So first let's start with the point of discontinuity. Now remember, the point of discontinuity, if you remember looking at your notes, is also the same thing as our excluded value. Is the value that x cannot be that will make our function undefined. So off to the side here, I'm going to figure out what will make this function undefined. If I plug in -3, well then that makes the denominator 0, and we can't have that. So that is our point of discontinuity, -3. Okay, now the next thing, vertical asymptote. Well, we find that by looking at the denominator here of our rational, and we do the same thing. Just like the excluded value, our vertical asymptote, VA, is x equals, remember x is a liar, x equals -3. And then we find our horizontal asymptote by looking at the number to the outside, which is, so HA, and that's a horizontal line, so that's y equals -1. Now with the domain, I'll write that down here. The nice thing about the domain is that that value we get the domain from is the same thing we get it from the same place that we get our excluded value and our vertical asymptote. So I know in this graph that I'm about to draw that I can have all values of x, so all real numbers, except for where my vertical asymptote lands, which is at -3. And the same thing goes for the range, which is, remember, our y values, and domain is our x values. So for range of our y values, it's everything, or all real numbers, except where my horizontal asymptote is, which is at -1. Now let's choose a new color. Now the next thing we want to do is actually sketch this graph. So if you remember our steps, first thing is sketch our vertical asymptote and our horizontal asymptote. So let's do that. So x equals -3, so that's right here. And remember, it's a dashed line because it can't ever actually be that value, so we want to symbolize that by making a dashed line. And then the horizontal asymptote is at -1, so that will go here. Now our next step is we want to draw what we call an anchor point, because that's going to tell us where we actually start our graph. We do that by first starting at the center of your graph and pick an x value that's to the right and to the left. So in this case we'll have -2 and -4, and just find the y value for that point. So f of -2, I'm going to plug it into the original equation or function. So 1 over -2 plus 3 minus 1. So now -2 plus 3, that's plus 1. So then we have 1 over 1, which is just 1. And then subtract 1 is 0. So our first point is at -2 and 0, right there. And then you're going to do the same thing for the -4 on the left. You're going to figure out, what is that? What's the point there? Well, if I plug that in back into my original equation, -4 plus 3 is -1. 1 over -1 is -1. And then -1 minus 1 is -2. So then my other point is over here. And the nice thing about these anchor points, is that once you find one, you can just go directly opposite in the diagonal direction to the other side, because they're symmetrical. Okay? At least when we're referring to these functions now. In the future, that won't work as well. But for now, that does work when we have these reciprocal functions. So once we have your anchor points, draw a line that gets really close to your asymptote but doesn't quite touch, because it never does. And then do the same thing going towards the horizontal. And then you're going to do the same thing coming from your other anchor point on the other side, going really close to the vertical asymptote, and then getting really close to the horizontal asymptote, but never actually touching. Okay? Now let's go on to number 2. So first thing we want to find is our point, our excluded value. So we go to our denominator here, and we say, oh, well, -4 will make it undefined. So there's our excluded value, or point of discontinuity. Then we find our vertical asymptote. Vertical asymptote is x is the liar, so -4. Horizontal asymptote is y equals -2. Then let's find our domain and range. Okay, so again, remember it's everything. It's going to be all real numbers except for the same value as our vertical asymptote, which is -4. And then for our range, it's going to be all real numbers except for, or not including, -2, which is also our horizontal asymptote here. And now we need to graph this. Okay, so let's start with our vertical asymptotes. First at -4, go up, dashed line, going vertically, and then at y equals -2, dashed line, and then from the center, I'm going to go right and pick a point, pick an x value, which is -3, and then to the left, pick a value, which is -5. And I plug in -3. Let's see. So that's going to be -3 plus 4 is going to be 1. And remember, don't forget, there's a negative out here to the left of our function here. So don't forget to include that. Now, when you have a negative located here, you can apply it either to the numerator or the denominator. I always play it safe and apply it to your numerator. It just makes life easier that way. So now I know that this number is actually -1 minus 2. So -1 minus 2 is -3. And then if I plug in -5, -5 plus 4 is -1. But then I also have this negative out here, so then it becomes positive. So now it's 1 minus 2, which is going to be -1. So now let's plot those points. So now at -3 and -3, and at -5 and -1. And if you noticed, our anchor points are what we had on the last graph. Why is that? Because of this negative. If we remember our transformations, whenever you have a negative in front of the function, it causes a reflection across the x-axis. Or sometimes we just say it flips it. Okay? Or it flips it vertically. So now the last step is just sketch your graph like before. So from your anchor point, draw your line, going really close to the line, but not touching. Draw your line, really close to the line. Oh, that's a little off. Really close, but not touching. Really close, but not touching over here from your anchor point. And again from your anchor point, really close, but not touching, even though it looks like it's touching. It's good. All right. Doesn't have to be perfection. But don't. All right. Now the next one. Describe the transformation. What's happening? How is this different from our parent function f of x equals 1 over x? Okay. So now where we need to look is here at this value and here at this value to figure that out. Well, I know that x is a liar, And so if I'm looking at a horizontal shift, the horizontal shift we find by looking at our denominator, and x is a liar, so if it's plus 4, that means it's going to go to the left 4 units. And then for the vertical, we find that by looking out here, outside of the parent function, by whatever we add or subtract to it, and the vertical will be up 1 unit. And that's it. And then to the next one. Now, one thing we want to note here is that, remember, there's a negative here, so that causes a reflection across the x-axis. Or you could say it flips over the x-axis. Okay. Now let's find if there's any horizontal shift, and it's x plus 1. X is a liar, so that means we've got a shift moving to the left 1 unit. And this number outside here, the -2, tells us the vertical shift. So our vertical shift is going down 2 units. Okay, so let's go to the next one. Now we got to find the x and the y-intercepts, wherever these graphs actually cross the x and y axis. So what we have to remember is that for x-intercepts, y is going to be equal to 0. Wherever it crosses the x-axis, y is 0. And for y-intercepts, we know that x is equal to 0, because wherever it crosses the y-axis, x is equal to 0. So keep that in mind as we solve these. So starting with our x-intercept here, if I know that y is equal to 0 at the x-intercept, we'll then set it equal to 0. Now remember, f of x is also the same thing as y. So set that y equal to 0, and then rewrite the rest of the equation, or function, and then solve for x. And then that will tell us where it's at. So now the first step we want to do is we have a positive 1 over here. So let's subtract that from this side. And that cancels out there. Apologize. Okay, so now we'll have -1 over here and 1 over x minus 2. And now we have a fraction on one side, so what we can do is cross multiply. So now I'm going to do -1 times x minus 2, and then 1 times 1. And I'll rewrite that by showing the arrow here. And I'll rewrite, so we have -1 times x minus 2 equals 1 minus 1. 1 times 1, which is just 1. And now we need to distribute that -1 here. So we have -x plus 2, since we have a negative times a negative, which equals 1. And then we're going to isolate x. So we're going to subtract 2 from both sides. And then we have -x equals 1 minus 2, which is -1. And what I'll do is I'll multiply both sides times -1 to cancel out that negative. And now everything becomes positive. So now x equals 1. And our x-intercept is x equals 1. And we know that y is 0. Okay. Now for our y-intercept. Zoom out a little bit. Okay, so now for the y-intercept, for the y-intercept, x is equal to 0. So then set x equal to 0. So now let's change the f of x to y. And let's separate this just so you guys know it's separate from that. So now we'll have 1 over x is 0, so 0 minus 2, plus 1, and then just solve the rest. So now 0 cancels or goes away, so now it's just negative 1/2 plus 1, and it's plus a fraction, so that means I need to change this to a fraction, and then find a common denominator. So I'll multiply the top and the bottom times 2, so I can make them both halves, or make both of the denominators 2. And now I have negative 1/2 plus 2 over 2. So then y is equal to, see, negative 1, add the numerators, negative 1 plus 2 is just 1, so we have 1/2. So then our y-intercept is that x equals 0 and y equals 1/2. Okay, now we're going to find the x and y-intercepts for this function. So, same thing, if we're looking for the x-intercept, remember y is equal to 0, so set it equal to 0, and rewrite the function. Now, let's isolate x first by adding 5 to both sides. This cancels out. And then we have positive 5 here, negative in the front of the function. So what I'm going to do is I'm actually going to apply that negative to the 1 on the top. And that negative could apply to both either the numerator or the denominator. But just to be safe and to kind of make life easy, I always put it on the top towards the numerator. Okay, so, but you can't do both. The negative doesn't go to both the numerator and the denominator, it only goes to 1. So I'm going to apply it to the 1 here. So now I have x minus 4 on the bottom. And let's make this 5 a fraction. That way it can cross multiply here and here. So then I will have 5 times x minus 4 and 1 times negative 1, which is negative 1. And then I'm going to distribute that 5 here. So then my next step will look like this. Just rewrite it up here. So 5x minus 20 equals negative 1. And then again, you need to isolate that x. So let's add 20 to both sides to remove this 20 from here. And now we'll have 5x equals negative 1 plus 20, which is positive 19. And the last step would be divide both sides by 5 to rid ourselves of that 5 next to the x. And now we have 19 over 5. And if we were to do this on the calculator and put this in decimal form, then we would end up with, let's see here, 19 divided by 5, or 3.8. Okay? So now our actual point is either 19 over 5 and the y is 0, or 3.8 as x and y is 0. Same thing. Now let's look for the y-intercept. Okay, so now we know that x is equal to 0 in this case. So let's set x equal to 0, turn f of x into y. And remember, we have a negative there in front of our function, so I'm going to put it towards the top. Make x 0, minus 4, minus 5. Now that 0 kind of just cancels out there. So I have negative 1 over negative 4 minus 5. And remember these negatives here. A negative divided by a negative equals a positive. So that cancels out. And then in order to add a fraction and a whole number, I need to turn the whole number into a fraction and find a common denominator. So multiply that times 4 here and on the top, so I can make it into fourths. So now I'll have y equals 1 over 4 minus 5 times 4, which is 20. 1 times 4, which is 4. And then our answer will be 1 minus 20, which is negative 19 over 4. Okay, that's our y-intercept. And how we write that as an intercept, we do the x is 0, and the y value is 19 over 4. And same thing again. That is also equal to the decimal of negative 4.75. Okay, so there's our y-intercepts. Okay, so let's go over now to simplifying the expression here. Okay, let's just kind of zoom up on this one problem, on number 7. Okay, first thing we want to do is, this is just multiplication, so what we're going to do is, at the same time, we're going to combine the top, because remember with multiplying fractions, we combine the numerator and the denominator by multiplication. But when we simplify, we also want to try to cancel out like factors. So what I'm going to do as I combine, I'm going to break down each of these numbers. Or in other words, use like the birthday cake method, if you guys remember. So this 4, if I use my birthday cake, divide by 2, divide by 2. Well, the factors are just 2 and 2. And you guys probably already knew that. You knew that 2 times 2 is 4, but I just want you to see that. So now 2 times 2, and then break down the n, which is also n times n, and then times 7. And then on the bottom, we have a 9, which is also 3 times 3, and 10, which is 5 times 2. And remember, you want to break it down into its smallest factors so that we can cancel out, top and bottom. So now, I have a 2 up here, which I can cancel down here. I have no more 2's to cancel out, but I can cancel out an n here and here. But then there's no more n, so I can't cancel this one, and there's no 7. And these 3's and 5's don't have anything else to cancel each other out either. So now what I'm left with is a 2, an n, and a 7 on the top, a 3, a 3, and a 5. So now what I'm going to do last is combine all those factors into my final answer. So now 2 times 7 is 14 times n, and then 3 times 3 is 9, times 5 is, 45. Okay, and that is my final answer for that one. So now let's go over to number 8. So now number 8, the steps are pretty much just the same, except for the first one. If you guys remember, we went over multiplying and dividing. When you divide, and you have division here, you need to flip the second expression. Okay? And then the division becomes multiplication. So rewrite the first one. Now you're going to flip the second one with basically put the 5n on the top, 9n to the 4th on the bottom. And now you're just dealing with multiplication. So it's one extra step, but pretty much the same idea. So now again, combine the top and break it down. So 6 is 3 times 2. And then I have 5 on the other side times n. And then the first one on the denominator in the bottom is 2 times n times 9, which is also 3 times 3. And then I'm going to break down that n to the 4th into 4 n's. Okay? Now we can cancel out top and bottom, or numerator and denominator. So now I have a 3 here and 1 here. I have a 2 here and a 2 here. I have no 5's on the bottom, so I can't cancel that. I have an n here and an n here. So that's all I can cancel out. So now I have a 3 and 1, 2, 3, 4 n's. So now my final answer will be 5 on the top, and on the bottom I have 3 n to the 4th. Okay. Now for number 9. Number 9. Now we've got a binomial down here and here. But the principle is still the same. We still want to factor everything out, combine them, and try to cancel out. Okay. So first thing let's do is let's combine. Okay. So let's draw this long division symbol or fraction symbol. And we have 2 in the front from this first term. Then it's times n squared minus 4n plus 4. But remember what I told you, let's break it down. Now to break down this trinomial, we're going to have to factor it by doing reverse foiling. I know if I have 1 here as my leading term, then My first terms are just n. And then I say, what numbers multiply to positive 4 but add up to negative 4? Well, I know 2 and 2 would work, and I would need those to be negative and negative. Now on the bottom of the denominator here, let's see if I can take out a GCF. And here I can take out a 2. So I'll take out a 2, and I'm left with n minus 2. And you can already see that we're going to be able to cancel something here. And then over here, that we can't really factor anything with this n plus 2, so just rewrite that as multiplied times n plus 2. Now it's time to cancel out the factors. This 2 goes away, and I can remove an n minus 2 and an n minus 2, and then I'm left with n minus 2 over n plus 2. So there's my final simplified rational. N minus 2 over n plus 2. Okay. Now, again, division. Division means flip. You're dividing a fraction, you're dividing a rational, you got to flip that second fractional. I just said fractional, I meant rational. Okay, so now, let's rewrite the problem. 1 over n plus 10, the first expression doesn't flip, the second one does, and the sign changes to multiplication. So now we have n squared on top, minus 3n, plus 2, over n minus 2. Now, again, remember we're going to factor, combine and factor. So we have a 1 over here times this trinomial. So that 1's not going to change anything, so I can leave that out. But I know I'm going to have to factor this one. So what two numbers multiply to 2 and add to negative 3? Well, first of all, we put the n's there. Well, I know if I have 2 and 1, that'll add to 3. And they'll both have to be negative, so I can have negative 3. And then on the bottom, we combine this factor and this factor, which I can't really factor n plus 10 or n minus 2, so I just rewrite it as n plus 10 times n minus 2. And then, as you guys probably already guessed, now I can cancel out these factors, n minus 2 and n minus 2, and I'm just left with n minus 1 over n plus 10. And there we go. Okay, that's the end of page 1. I'm going to do another video on page 2.